In this lesson, we're going to perform arithmetic operations on functions. Notations for function operations. Let's say you're given the two functions you see below. F of x equals x squared minus 3x plus 7, and g of x equals negative 3x squared minus 7x plus 7. The addition operation is if you see f plus g of x, that means you're going to take these two functions, both f of x and g of x, and simply add them together. When you see f minus g of x, that simply means you're going to take the two functions and subtract them. If you see f times g of x, meaning you see f and g joined together with nothing in between them, when they're stuck together like that, that indicates you're going to be multiplying the two functions. And if you see one function over the other with a fraction bar, then that means that you're going to be dividing the two functions. So in this example here, we are asked to find f plus g of x. That means we're going to take the two given functions and simply add them together. And recall, when you're adding, you're going to be combining like terms, which means make sure you combine the secondary degree terms together. You're also going to combine the first degree terms, and then your constants, your numbers, will be last. So let's begin first. Again, we're going to add these two functions together. If we take a look at our squared terms, we have a positive 1 and a negative 3. That's going to give us negative 2x squared. For our first degree terms, we have a negative 3 and a negative 7. Signs are the same, so keep the sign and add the numbers. That will give us negative 10x. And lastly, we have our constants, our numbers. 7 plus 7 is going to give us 14. So the answer when we combine these two functions is negative 2x squared minus 10x plus 14. In this example, we're asked to find f minus g of x. That means we're going to subtract these two functions. So keep in mind that because this group g of x has the negative in front of it, everyone that is in that group of g of x, we have to change their signs to their opposite. So once we do that and combine our terms, combine the second degree terms, combine the first degree terms, and combine our constants, what you should be left with is, let me give you a moment to look at it. I want you to work it. All right, let's see what you came up with. So what you should have when combining those terms, notice here we changed the sign of everyone in that second group to their opposites. From there, it's just a matter of combining like terms, which you should already know how to do. So your final answer should be 4x squared plus 4x. What happens to the 7s? They canceled out. Notice they are opposites of each other, so they don't exist anymore. We're just left again with 4x squared plus 4x. In this example, we're asked to find f plus g of 1. And what that means is we're going to, yes, combine these two functions together or add them. And then we're going to plug in a negative 1 to evaluate the function. Now you can do this one or two ways. You can go ahead and add the two functions first, and then afterwards plug in your 1 to evaluate that. Or you can do it all at one time go ahead and plug in your 1 while you are combining the two. So let's see what that looks like. So again, here we have a plus sign between them, which means that you're adding the two functions. So here we have the two functions side by side to be added, and we can do it all in one by also plugging in a 1 in x's place. So remove all x's, replace them with 1. When we do so, it's going to look like so. And now we're going to go ahead and proceed with combining or simplifying the right side of the equation. So we know that 1 squared is 1. So what you're going to wind up having here is 1 plus 1, which all of this is going to give you 2. 3 times 1 is 3, and then 3 plus 5 is going to give us 8. And 2 plus 8 we know to be 10, so therefore f plus g of 1 will equal 10. So again, with this process, we did it all together in one, both adding it and plugging in our value of 1 to be evaluated, and we get an output of 10. The other option is you can go ahead and add the two functions first and get your sum. So notice here that the squared terms, there's not another squared term to combine with. So that is the first term is just going to be x squared. For the x, there's also not another x term to combine with, so your second term is going to be plus 3x. We do have constants that are the same, so we're going to go ahead and add those. 1 plus 5 is going to give us 6. So when we combine those two functions, we're going to get x squared plus 3x plus 6. And now that we have their sum, we can evaluate that for 1. In other words, remove all the x's and now plug in the 1 and do the math. 1 squared equals 1. 3 times 1 is 3, so we're going to add 1 plus 3 plus 9, and when we do that, we also get 10, the same answer as we did in method 1. So either way you can do it. You can do it all together, or you can add the function first and then evaluate it afterwards, plug in your number. Alright, so here we're given two functions, f of x and g of x, and we're asked to find f minus g of x and then to evaluate it for -3. So here we are subtracting the two functions, and then we're going to evaluate it for -3. Now recall, as we showed you in the previous example, there's two ways you can do it. One way is you can do it all together, your subtraction and plugging in at the same time, or you can go ahead and combine the two and then afterwards evaluate it. So I'm going to go ahead and do the second option, which is to go ahead and subtract the two functions first, and then after I subtract the two functions, we're going to proceed with plugging in a -3 to evaluate it. So here are the two functions that are going to be subtracted. Now recall, because that second group has that negative in front of it, everyone in that second group has to be changed to their opposite. So then you'll have -3x minus 5. And once we combine that with the other terms, we'll have x squared minus 3x minus 4, because once you combine the positive 1 with the -5, then you will get -4. So now that we've subtracted the two functions, we're now going to go ahead and plug in a -3 in x's place. So let's remove all x's and replace them with -3. When we do so, it's going to look like so. So now we need to just go ahead and simplify and do the math on the right side. -3 squared we know is 9. And then here we have -3 times -3, which is +9. Next, we're going to have 9 plus 9, which is 18, and then 18 take away 4 is going to give us 14 as our output. So f minus g of negative 3 then will equal 14. Here we're given two functions, f of x and g of x, and we're asked to find f times g of 5. Notice here that when you see the functions stuck together with nothing in between them, meaning no plus, no minus, that indicates they're being multiplied. So we want to multiply these two functions and then evaluate it for 5. So let's go ahead and proceed with the process. So here are the two functions, and these are binomials. And yes, to multiply binomials, you can use FOIL, first, outer, inner, last, and then after you get your result, you'll then plug in a 5 and evaluate the function. But that way may seems a little bit longer doing the whole FOIL, so let's do the other option. We'll do it all in one, meaning we're going to go ahead and plug in our 5 and do the whole thing together in terms of the process. So I'm going to remove all the x's and replace them with 5. When we do so, it looks like so. Now let's do the math. 5 squared is 25, and then 25 plus 1 is 26. On the other binomial, we have 3 times 5, which is 15, and 15 plus 5 is going to give us 20. Now recall that they are joined together or stuck together, which means they're being multiplied, so we still have to do the multiplication. So when we multiply 26 times 20, what we're going to get is a result of 520. And there you have it. We have evaluated f times g of 5. In this example, we're asked to find f over g of 0 and then to give the domain of the function. So anytime you have a function over the other, that is a form of division. So let's go ahead. We're going to set up our problem here. We're going to put the f of x function on top, and on the bottom we're going to have the g of x function. Now actually that is pretty much all that you have to do in terms of place the functions there. We're asked to find the domain of the function and also to plug in a 0 into the function. Let's go ahead and plug in the 0. If we remove all the x's and replace them with 0, it's going to look like so. So we can see very clearly on top we will be left with just a 1, and on bottom we will be left with just a 5. So f over g of 0 then will equal 1/5. And now we want to find the domain of this function. Remember, when you have a rational expression, it is the bottom that determines the domain of the functions, the allowable x values. So you would take the bottom and set it equal to 0 and solve for x, and that will determine the domain of the function. So if we take the bottom, 3x plus 5, set it equal to 0, the first step to solving for x is to subtract 5 from each side, divide by 3, whatever you do to one side, you do to the other, and x equals -5/3. So to write the domain, we would say that the domain of this function includes all real numbers except not -5/3, because that is the number that would make it undefined. So that is restricted from the domain of this function. So to write it in interval notation form, we would say the domain includes all numbers from negative infinity to negative 5/3 and from negative 5/3, not including 5/3, all the way to positive infinity. And that's it for this lesson. Thank you for watching math videos on PowerPoint with Dr. Speights. I hope you learned something in this lesson. Please feel free to like, share, and subscribe.